Hi, I'm Tianshi Li from Carnegie Mellon University. I'm happy to present our paper, Alert Now or Never, Understanding and Predicting Notification Preferences of Smartphone Users on behalf of my co-authors, Julia, Miguel, Jason, and Jeff. Notifications are an indispensable feature of today's mobile devices. However, untimely notifications can lead to a variety of negative implications on users. Researchers have proposed two main mitigation approaches for this problem. The first approach is to defer the delivery of notifications to the next detected opportune moment. The second approach is to emulate users' actions on notifications, such as discarding notifications frequently dismissed by users. However, these approaches are grounded in assumptions about how users want a system to deliver their notifications that have not been formally tested. Next, I'm going to introduce key limitations of these approaches and then introduce our research questions to address these issues. The first limitation is that deferment-based methods often have the risk of missing urgent notifications, as it mainly focuses on the context while not take the notification content into account. The bounded deferral method was proposed as a method to address this issue, while we still lack a systematic understanding regarding how different factors affect users' notification preferences. Therefore, our first research question is, what factors affect users' notification preferences, and how do these factors affect notification preferences? The second problem is that users' actions do not always represent how they think. The authors of PrefManner have alluded to this issue by discussing an exceptional case regarding reminder notifications. However, we still lack a systematic and rigorous understanding about the relationship between user actions and their preferences. In our second research question, we want to study what are the reasons that cause users to act upon notifications in a certain way, and how do users' actions on their notifications correlate with their preferences. The third issue is subjective labels are costly to obtain, which makes it difficult to adapt to user preferences on the fly. Users' observable actions are easier to obtain at a large scale, while we don't understand much about their relationship with users' preferences. So in the last research question, we want to build machine learning models to predict users' delivery preferences solely using user actions and compare it with models built using user-labeled data. To tackle the three questions, we conducted an experience sampling study with 35 Android users for a week to directly probe how they wanted their notifications to be delivered and record how they reacted to the notifications in the meanwhile. Data collection for the study was conducted remotely via a custom Android app. Over the course of the study, participants responded to two types of ESM tasks triggered by notification events. Task 1 was triggered by notification seen events. The main question in the Task 1 survey is to select their preferred way to deliver this notification. The four options were Send Now, Alert Now, Send Now, Alert Later, Send Now, Never Alert, and Never Send. We also asked the user to provide a free response to explain their choice. Task 2 was triggered by four types of user actions that remove a notification. The action type could be automatically detected, while we asked the user to specify whether they took the action immediately after seeing the notification and explain the reason. Now I'll introduce the key findings we derived from this dataset to answer the three research questions. First, we analyzed the 525 Task 1 responses collected in the first 5 days. We found that only 56% notifications were expected to be delivered with an immediate alert, indicating a strong need for reducing interruption. However, for other notifications, the ratios of Send Now, Never Alert and Never Send were significantly higher than Send Now, Alert Later, suggesting suppressing the alert was preferred than deferring the alert. Then, two researchers conducted an open coding analysis on users' reasons for their selected notification preferences. This table shows the resulting typology. We found that 91.6% of responses mentioned content-based factors, while only 15.3% mentioned contextual factors. This difference was statistically significant. Next, we analyzed the Task 2 responses and found out that there was no one-on-one mapping between users' preferences and behaviors. For example, sometimes users directly took action via the notification, and sometimes they did not directly act upon notification, such as open the app to reply to a message. These two groups represent very different behavior patterns, while the corresponding delivery preferences were very similar. Conversely, we also noticed notifications that users acted upon in a similar way, while the delivery preferences were very different. In this example, users tend to immediately cancel notifications, both if they did not need them or if they had already seen them elsewhere. However, users still wanted immediate alerts for about 2/3 of the notifications that they had seen elsewhere. Furthermore, we found that although some prior work used users' action type or response time alone as a proxy of users' preferences, our quantitative modeling experiments suggest otherwise. The accuracy of predicting preferences based on response time alone is only 56.9%, which is equivalent to always predicting send now, alert now. The accuracy based on action type is only 58.8%, which is only slightly better than the chance accuracy. Lastly, we built machine learning models to predict users' notification delivery preferences. To make the dataset more balanced, we kept the send now, alert now option and grouped the other 3 options into one new option. This chart summarizes the intuition behind the 3 classifiers we built and tested, including a generic classifier, a classifier personalized on users' subjective labels, and a classifier personalized on users' objective actions on notifications. The key idea of the user behavior personalized model is that we first train an SVM classifier using other users' data to predict preferences using user behaviors. And for the target user, our algorithm only needs to record how they reacted to previous notifications. For an incoming notification, our algorithm will aggregate user behaviors on past notifications with similar content and then use this SVM classifier to generate a preference prediction. Fortunately, our results showed that by aggregating past notifications of similar content, a model of notification delivery preferences personalized on user actions could achieve similar performance as a model personalized on user-labeled preferences. The best performance of the 2 personalized models were very close, which improved the performance of the generic model by 42% and 39% respectively. From our findings, we envision that future notification managers should use a more nuanced, holistic, and mixed initiative approach to ensure both accuracy and user control. Here we illustrate one possible idea inspired by the alert now or never finding and can be supported by our content-based classifiers. Basically, the system will predict an importance score for each notification based on its content and only alert the users about its delivery if the importance score exceeds a certain threshold that can be adjusted by the user. To sum up, our mixed methods ESM study found that Android users prefer mitigating interruptions by suppressing alerts over deferring notifications and ascribe their preferences to content-related factors than contextual factors. Although the relationship between your user's preference and behavior is messy, our ML model shows it is feasible to predict notification preferences using aggregated behavioral data and notification content. Finally, we argue that a more nuanced, holistic, mixed initiative notification management approach is needed to both free users from excessive disruption and keep them in control of important notifications. Thanks for watching, and I'm happy to take any questions.